So this time I'm going to discuss about CUSUM. So the purpose of CUSUM is to catch sneaky changes in data before they turn into big issues. Helps in monitoring process stability and identifying unusual variations. I already showed you how to predict the energy consumption for year 2023 using the baseline of year 2022. Just a recap, for year 2022, we saw how we used heating degree day and energy consumption to come up with an equation, a regression equation in the form of y equal to mx plus b. Once we create the equation using Excel, we can substitute the values of heating degree day for year 2023 in the equation and predict the energy consumption for year 2023. So these are the different ones, energy consumption, but this is predicted. So from the bills, you can get the actual consumption for year 2023. This is what we expect to have, and this is what we are actually having. So if the actual consumption for January is lower than the predicted consumption, what is it really telling you? Are we performing better or worse than what is expected? So 10,400, if you think that we are performing better, you are right, because we predicted an energy consumption of 10,485, but in reality, we are consuming less energy, means we are saving bills and we are saving carbon dioxide emissions. So that's a deviation of minus 85, because deviation is calculated as actual minus predicted. So negative means good, means we are consuming less energy. So once you are done calculating the deviation, calculate CUSUM by doing minus 85, that's the first month's deviation, plus minus 5, the second month's deviation, minus 90, plus minus 25, minus 115. So each time C is getting more and more negative. So this time just plus 30 means we are consuming more energy than what we expected. For September, it's actually worse, because we expected an energy consumption of 7,425, but the energy consumption in reality is higher, which is 7,455. So that is why plus 3. So if you do minus 305 plus 30, you will see that the negativity reduced. But overall, finally, at the end of December, means if you add all of them, you are going to get minus 85. Means overall, it showed an improvement, means we are consuming less energy than what we expected. So this is the graph of the CUSUM and shows a reduction, means downward trend. Key observations: the CUSUM value steadily decreases throughout the year, indicating a decrease in energy usage compared to the baseline. The baseline is year 2022, because we used year 2022 to create an equation. So what might be the potential causes? Decreased activity or reduced operating hours. So say in year 2022, the bank actually had operating hours from 9 to 5 p.m. but year 2023 is 9 to 4 p.m. So the equipment are now running for a lower period of time, because it needs to heat or cool the building for a lower period of time. So that is why the energy consumption reduced. The other reason can be equipment efficiency. So you might want to check the asset database if that happens for your project, to check if there was any HVAC equipment upgrade. For example, the regular boiler is replaced by a condensing boiler, which is more efficient. So that is causing the energy reduction. So it can be because of lower occupancy and the HVAC equipment is running for a lower period of time, or there can be an equipment efficiency upgrade. Conclusion: the CUSUM analysis provides a clear picture of energy performance over time, helping identify when and where the deviations occur. It serves as a valuable tool for ongoing energy management and optimization. Recap of tools we used: regression analysis, digging into data like a treasure hunt; CUSUM charts, like plotting your building's energy adventures; outlier analysis, keeping those energy consumers in check. Next, I'm going to demonstrate how to do CUSUM analysis using Excel. This is the Excel worksheet for CUSUM, and the year 2022 month energy consumption and heating degree are given. So we are going to predict the energy consumption using the regression equation for year 2022. So I'm again doing it. So basically this is a recap, and also I'm going to show you how to do the CUSUM. So again, to calculate the slope, just use the formula. So let's first do it here actually. Equal to slope. Known y's is the energy consumption, that is the dependent variable. And x's are the heating degree days for the baseline year 2022. Next, the intercept. Again, the y's are the energy consumption and the x's are the heating degree days. Done. We are done calculating the slope and intercept. So basically that is the heavy part we're done with. So I'm just going to round the values so that we can create a nice equation, although that is not necessary. So if you want, you can represent the equation here just like we did before using the concatenate function. So I'm not going to repeat it, but let's predict the energy consumption using the equation equal to mx plus b. M is the slope, this one, but absolute reference it by pressing F4 because we are going to drag the cell for the rest of the month. So we don't want it to change. Times the heating degree day for year 2023 is 160. That is going to change, so I'm not going to absolute reference it. See, there is no dollar sign before it, means it's going to change depending on the month. Plus the intercept. Intercept, we want to absolute reference it again because we don't want it to change. The equation remains the same for M and B, only the X will change. So again, press F4. Done. So here we have the predicted energy consumption for year 2023. Next, calculate the deviation, easy. Actual minus predicted, which is a negative, means we are performing better. So CUSUM is first, it's minus 85, and then it will add up. So for the second month, it's going to be minus 5, that is the deviation of the second month, plus the deviation of the first month. So the first month, just copy it, L4. For the second month, see, I highlighted it so that you can see it. The February's deviation plus the deviation from the first month. So since this formula is done for February, just drag and drop. See, it's following the same pattern. It's following the same pattern. So minus 395 is the CUSUM finally. So if you add all of them, you can also see it from here. See, sum is minus 395. So let's do a CUSUM chart. And you can do any kind of chart, it's up to you what kind you choose. But for now, let's choose this one. Label it as CUSUM kilowatt hour. So you can label again the y-axis, the vertical axis as the CUSUM kilowatt hour. Actually, that is not necessary because we already did the title here and shows the month. So let's remove it for now. I think it's good enough. So this shows a downward trend, so which means that it is performing better than what we expected, means the energy consumption is lower than what we expected. That's